Hello and welcome to 5 to a 5 day 19. So first of all, before we read the question, we are going to analyze the graph so we thoroughly understand it, and we will use our forever omnipresent tool Oyxirga, Oyxirga. So the origin, we have no numbers, no sense of scale, so we treat it like it's a 0, 0. The y-axis is position, not given any units, but we assume it's probably meters, and it doesn't matter. Time, also no units, but we might infer or create an example using seconds. The intercepts, there are none. There are no intercepts in this graph, which is curious. And then we figure out our read. What we can read is position and time. Our instantaneous, our final, our initial positions, and the times. The gradient of the slope is dividing the axes, so delta x over delta t, which has units of meters and seconds. So that tells us that it's giving us the velocity. The slope of this graph, the gradient of the graph, is the velocity. The area in this case is multiplying the axes. X times t, which is meters times seconds, meters seconds. That doesn't represent anything. So we don't think that the area is going to tell us anything meaningful. So now let's analyze. In terms of the reading, the position, what's going on is the position is at the most extreme positive value it has. And then, so if we have a number line, it looks like this, positive and negative. It's starting out, and if this is 0, it is starting out here, and it is moving toward lower numbers, which means its velocity is negative. It's headed toward the negative direction. So the points are becoming lower and lower and lower and lower, and at the end it reaches a minimum value, the closest to 0 it gets, although it doesn't get there. Now, in terms of the velocity itself, the velocity is the slope, and at all times we see the slope is negative. And if we draw the tangent to the curve at each of these places, we can see here that the slope is 0. So it's starting out with, it's about 0, and what's happening to it is it's getting steeper, all the while being negative. So here we have the biggest, so this might be like -6, and this might be -4, and this might be -2. And of course, that's what we said, is that it is moving toward negative values, and we can then see it's getting faster. So if we were to consider equal intervals of time, if it starts here like this, it starts out moving slowly, and the next interval of time, it is traveling more quickly. And so it'll travel farther, like so. And so this is what the picture looks like if we use a motion dot diagram, indicating where it is at intervals of time. So that's what's going on with the velocity. The velocity is increasing in magnitude all the while in the negative direction. Increasing in magnitude. And the area tells us nothing meaningful. All right, now we have a handle on this. We go to the question. For each of the following, justify the answer using specific reference to the graph. Is the object's velocity positive or negative? Clearly negative. Now, in a question like this for the AP, this may be listed as a 1-point question. Putting an X next to the negative will earn you 0, even though it's correct. They only assign a point for the justification. And that's very, very important. And again, that's due diligence. That's not being indolent. It's about focusing on precision here, because the justification is what matters. Many students fall down on that. They don't do what's being asked. So the velocity is negative. The velocity, represented by the slope, is negative throughout. And we can even go further, as evidenced by the tangents added to the graph above. Next question, is the object speeding up, slowing down, or not changing speed? We already know the answer to this. This is speeding up. The slope is negative throughout. The speed is increasing because the magnitude, steepness, is increasing over time. Or we could say magnitude of the slope or the steepness is increasing over time. Lastly, is the object's acceleration positive, negative, or zero? The direction of the acceleration is the direction of the force causing it, or the direction of increasing speed. Now, if we go back and look at our diagram up here, our motion dot diagram, if you imagine some force, let's say there's a person here exerting a force causing this object to behave this way, is that person exerting a force to the negative direction or to the positive direction? Well, very clearly we could see this person would be pulling on it, causing it to speed up. So we know the acceleration is negative. And again, our justification, the acceleration is negative because the object is increasing speed in the negative direction period. So again, we have our justifications. We get 3 points for the justifications. 3 correct answers earn us nothing.